Good afternoon, everyone, and welcome to our second Launch and Learn webinar in the series, where you will discover how to design your applications without EMI and EMC concerns. Let me introduce myself first. My name is Tisa Sitar, and I'm a marketing officer at Infinite Simulation Systems and a moderator of this webinar. Before we start, please let's just wait 1 or 2 more minutes for everyone else to join, and then we will proceed further. Okay, so let's begin. First, quick instructions on the webinar tool you're currently using. As you can see, you have different options. You can minimize, maximize the menu, choose for a full screen mode. You cannot unmute yourself. So if you have any question, please just write the question down under the question tab, and all the answers will be provided at the end of this webinar. So again, do not try to unmute, do not raise your hand, just write the question down and we will come back with the answer at the end. Please also note that the webinar is being recorded and the recording will be shared with you together with the presentation slides after the webinar. Today, I'm joined by Odysseas Votsis, application engineer, who will tell you more about designing applications without EMI and EMC concerns. So looking at the agenda, I will just give a very quick introduction of Infinite Simulation Systems for those that might do not know us yet. And then I will give my word to Odysseas, who will cover all the other agenda topics. So Infinite Simulation Systems, we are Ansys Elite Channel Partner for the Benelux region, being active in computer-aided engineering for more than 30 years now. We are located in the Netherlands in a city called Breda. You can also see our office on the image that it's presented in the slide. So with broad product portfolio, we basically mean that we do not only cover electronics, but we are active in many other domains as well, such as mechanics, fluids, optics, photonics, and more. Besides, Ansys simulation solutions are applicable across various industries and other applications. Our main goal is to improve your design efficiency, of course, but we do not only distribute the simulation solutions, we also offer consultancy and support. Apart from that, we also provide theoretical and practical trainings where you can learn how to actually use Ansys simulation tools in practice. So everything that I've just mentioned, you can check and read more about on our new website. It was launched 2 months ago, and by scanning this QR code, you can explore and read more about us, about our solutions, and so on. So again, feel free, scan the QR code and enjoy. Now we're gonna start for real, and I'm gonna give my word to Odysseas.
Thank you very much, Tisa, and thanks everybody who are joining this webinar. Once again, we are very happy to have you in this lunch break of ours, and we hope to make your lunch even tastier. So let's get ahead. Traditionally, as you know, companies have a design, build, fix, test cycle, and this this approach can be expensive and time-consuming nowadays. Furthermore, design rules and best practices may not provide engineers with enough guidance to properly design modern cutting-edge products. By using simulation, virtual models and prototypes can be created and simulated, giving engineers more freedom via virtual testing. This will help engineers to have a better insight of their designs, but also have a higher degree of confidence that the physical tests that they will do run they will be successful. If simulation is used as a design tool early on in the development process, it can greatly benefit and cut down costs. Here in this graph, we can see that with the traditional approach, if there is an actual problem, it can be detected only when there is a prototype. And to resolve this in this phase, it can be 100-fold more costly, not only in terms of money, but also time. If problems arise even later in the development phase, the costs of time and money increase exponentially. Working with simulation tools early in the design phase, engineers can predict issues and work on solutions or changes very quickly, and without the need of course, physical testing. This also seals out problems that might occur very late in the development phase, which can be detrimental in costs. Now let's talk a little bit about electronic design challenges. Engineers must address a wide variety of design requirements when designing electronic systems. Those range from electrical, such as signal and power integrity, thermal, such as implementation of optimal cooling strategies, or even mechanical, the ability to withstand shock and vibrations. Furthermore, products are expected to meet life requirements to ensure that they meet their intended function for at least a specified amount of time. Engineers also need to consider the effects of manufacturing, transportation, and product operation as part of their design processes. Ansys provides a suite of tools and workflows that addresses a wide range of electronics reliability concerns. Each aspect, the electrical, thermal, mechanical, multiphysics, play a key role in understanding of how electronic systems operate and perform in a variety of applications. In each webinar series, we will give focus to one of those elements. We started off with our first webinar, which was in signal and power integrity. Today, we will be talking about EMI EMC concerns, and next webinar will be about thermal reliability, and lastly, we will have the webinar about lifetime predictions. So let's go ahead and see why is there a need for EMI EMC. Now, electromagnetic compatibility is concerned with the unintentional generation, propagation, and reception of electromagnetic energy, which may cause unwanted effects. In today's world, modern devices are starting to become very complex and with higher functionality. This can cause more EMI and EMC issues to arise, and it makes it harder for us engineers to predict the device behavior. Subpar EMI and EMC designs can also cause poor device efficiency or even failure. Ultimately, though, what we need to do is follow many strict compliance standards that need to be fulfilled before the product can be marketable, which leads to the need of fully understanding our design in electromagnetically subjects. Now, EMI and EMC can be divided into two general categories: emission level and immunity level requirements. For emission requirements, it can be either conducted or radiated emissions, and of course, there are regulatory standards for both of them. Then for immunity level requirements, we again have radiated and conducted immunity, but also we have ESD tests, which are tests for immunity and discharge. Finally, we have coupled effects and currents to take into account for immunity. This can be on a shield of a cable or on a PCB with a power delivery network. And really, at the heart of EMI and EMC lies signal and power integrity concerns. We covered the topic of signal and power integrity in more detail on our previous webinar, so please let us know if you want a recording of it. Now, EMI and EMC challenges are rising in all sorts of different domains and applications, from PCBs that we want to see the burst source or the ESD waveform and produce radiated and conducted emissions to see the results. Then another big challenge in EMC is cable harnesses. We want to control the crosstalk or the immunity and radiation of the cable. We want good cable design and shielding to protect from interferences. Filters also are a big role in EMC. So proper design of filters or even placement of them in our devices is key for a successful product. And now, let's see how simulation can tackle all of these problems. So, in the simulation domain for EMI and EMC, there are multiple stages, you can say, of effort and results that we can expect. It's up to us engineers to see how, let's say, far we want to go into the rabbit hole. As you can see in the graph here, we can characterize this as how much effort is required versus the benefits we get from simulation. We can start simulating very early on the design phase for the so-called design improvements, as you see here in the graph. These are simulation tests that are aimed towards looking at root causes, so looking at interference, signal and power integrity rules, crosstalk levels, or even filter and decoupling capacitors placement. And these simulations, of course, can be set up very easily and quickly and run in a matter of seconds or even minutes. So you can analyze potential issues that can cause EMI, EMC concerns very fast, very accurately, and very reliably. In this stage of testing, we can get results with minimal effort in fast time. So that's why you see that the slope of the graph is quite steep. Then moving on, we can combine different types of subsystems or coupled components into our full product simulation. So we will have our full product and we can simulate the whole of it. For this, we will need to combine electromagnetic simulations along with circuit simulation. And then we can look at radiated and coupled emissions for our product. This is, of course, very fruitful and necessary to do in certain designs. However, it does require some more effort from the engineer in comparison to the first design improvements phase. And lastly, of course, if we want to be 100% sure that our device will pass the compliance test, what we can do, we can simulate the whole test bench. Of course, this takes the most effort and skill to do. However, Ansys does provide templates for certain test bench and compliance tests, as we will see later on. This approach of making the whole test bench and the whole virtual compliance is an approach that uses different building blocks and solvers. So the engineer must have a high degree of skill in simulation in order to do so. Now, since we have identified that all EMI and EMC is a very broad subject with various applications and domains, I would like to focus on the PCB as an example to showcase how simulation can help with EMI and EMC concerns on the three stages that we talked in the previous slide. So for the first stage, for design improvements on a PCB level, we can use SI wave tool, which we have talked in our previous webinar with more detail. However, I want to also talk about it here for specifically EMI concerns. We talked about how easy it is to scan the board for various violations that may cause issues in our previous webinar. And this is because SI Wave has a geometry-based design rule checker specifically for EMI parameters. One example of this can be seen in the middle picture. There we have a net crossing, a split ground plane, which can actually cause issues in practice. So we have to look if action is required on our design to minimize voltage swings and emissions. One such action could be maybe placing some stitching capacitors. Location of the capacitors and values of the capacitors can be optimized via SI wave. It's very easy and powerful to be able to do what-if scenarios on our design with these various rule checkers. And then once we have done this preliminary work and these rule checkers, we can run the full electromagnetic simulation and then look at the field levels of the PCB. Here on the right picture, you can see the field levels of this trace with and without capacitors. So you can see this is just one example of a design issue that can be quickly addressed and tackled with simulation. Then to do a near and far field type of simulation, we will need to do a little bit extra work. We will need to go from the electromagnetic side of SI wave to the circuit side solvers in a co-simulation manner. So electromagnetic simulation and circuit simulation will be combined together. The way it works is that we're extracting the S parameters from the PCB, and then we push this into a circuit schematic as a type of a black box representation. We then connect the transient sources of the schematic. And here on the top right, for example, you can see we have connected two differential sources that give power to the PCB. And in the middle is the black box representation that we talked. Once we have the solutions from the transient circuit simulation, then we push these results back to the electromagnetic model, so back to SI wave. So these excitations go back as voltages and currents. And then we can compare and make the near and far fields for different types of solutions. And of course, we can have different types of what-if scenarios. We can also very easily in SI wave do a susceptibility analysis where a plane wave is hitting the PCB. And while hitting the PCB, how are these induced voltages of the plane wave are exciting the different nets on the board and at which frequency? We can see all of this in SI wave. And again, in a very easy and simple manner. This is an easy simulation to perform in order to get further insight and get ahead of any issues that might arise on an EMI and EMC level. So we have covered the first stage of the EMC simulation range, but for our second stage, for the full product simulation, we will need a 3D solver because usually products are in 3D. And yeah, as I have said in the previous webinar, SI wave is a 2.5D solver. So now we will need another tool that is capable of 3D full wave simulation. And this tool is Ansys HFSS. Ansys HFSS is a general purpose full wave 3D electromagnetic design and simulation tool for various things such as antennas, chips, packages, PCBs, RF and microwave components, and many more. It's the flagship product of Ansys with over 30 years of development. Since it's a general 3D electromagnetic model tool, it can handle many different domains and applications. Some examples of simulation within HFSS can be seen here. So we can have car autonomy applications, filters, signal integrity, or even biocompatibility. And HFSS can help with all of these types of simulations. I will not go much more into the detail of HFSS because this will take the whole webinar, so I will just focus more on EMI EMC. Now, the two tools, HFSS and SI wave, are also integrated with each other with HFSS solver integration. This can act as a validation frontend for a rigorous HFSS solve of a PCB after performing the design iterations and the what-if scenarios that we talked before via the SI wave engine. By combining the two tools, we can have super accurate results coming from the 3D simulation, but also very fast results coming from the 2.5D simulation. And of course, HFSS can produce 3D plots and help us have full insight of our design. Here in the pictures, you can see the near and the far fields of a PCB that is solved with HFSS and SI wave combined. And you can see and have details. So now, having the tool to work on a 3D environment, we can really take advantage of this and build up, as we said, the whole virtual compliance test and do a virtual compliance test bench. How we can do that? So let's look at the example again of the PCB and of the workflow that is taken into account. So for the radiated emission chamber test of a PCB, or the CISPR 25 level, as we have some of you might know, we take the solutions, the specialized solutions that SI wave have produced. Here we are taking the near fields that SI wave has seen, and we're taking this from the SI wave. Then we combine this with a 1D cross section of a cable harness, which we will excite both the cable and the PCB, and then we put this into the 3D simulation tool that is HFSS. And this way we are building our CISPR 25 test bench, as you see in the middle picture. So combining these two tools can help us have the test bench. However, we can go also a step further and now import this whole test bench into an anechoic chamber and run a simulation of the full test bench that will happen in the physical life later on when you want to make your product marketable. This is now just a data example of one of our clients that has used the simulation in order to simulate this test bench for a PCB. And you can see how accurate and how close the measurements and simulation is. You can see the accuracy of the simulation, even though it's such a complicated problem. Lastly, I would want to look for the ESD GAN test that is also prevalent in the and must be fulfilled in order to make some products marketable. So we have here in the picture an ESD GAN test on a device under test. And as I said, there are templates within Ansys tools, so you can just grab this whole test bench and just put your own device there and solve simply and easily, and have solved this in HFSS in the electromagnetic domain. And we can look at the fields and how the fields are coupled to the electronics components of our device under test, and basically make the virtual test as it is in the physical world. And you can see here it's just a transient simulation. It's just a small video that I have done. You see the ESD GAN is will hit now, and you see how the fields are propagating. So yeah, as a summary of everything, EMI and EMC design challenges are getting more and more complex in today's world. And we will have to have expertise in many different domains and applications, mainly conducted and radiated electromagnetic interference, if we want to shield ourselves from these problems. On the PCB level, EMI and EMC solutions and solvers can enable us near and far field emissions and radiation predictions, and also, of course, susceptibility analysis. But Ansys has further capabilities to have also 3D geometries and detailed 3D electromagnetic simulations, which are required if we want to have a very high degree of confidence and accuracy for our EMI and EMC concerns. And of course, by doing simulation and having it early in the development stage, we can address many requirements and reduce the risks of product delays and compliance failures. We can make ourselves, we can make our life easier and less stress-free for the physical test that will happen and will need to be passed in order for our product to be marketable. And with putting simulation early in the design process, we can really be stress-free. Thank you very much for your time. And I will give back to Tisa.
Hi, thank you, Odi. So before we proceed further to your questions, I would just like to share with you our contact details in case of any additional questions. If something was not clear, if you want more information, please feel free and contact us via emails provided, which you can see on the screen, or via the phone number below. Now, moving to the questions that have been asked, we received 2 questions. And the first one, Odi, it's how fast are the 3D simulations of the whole chamber?
Like, I will have to be honest with you. If you want to do a full 3D wave simulation of a whole anechoic chamber, you will need powerful machines to do so. However, Ansys has provided tools if you want to, let's say, not solve the whole chamber as it is, because as we know, a lot of the times we just need to focus on the PCB or on the antennas that are on the chamber. So Ansys has tools that we can basically solve the whole chamber, but only have data and results on this smaller, the antennas or the PCB. So this will cut down time a lot. So I would say that it really depends on the application, how fast it will be. It will take more time, and that's why we also have SI Wave as a tool to be fast and accurate. But for these longer and more rigorous full virtual compliance tests, it will be needed that you have a good machine, a little bit more time, but Ansys has tools and capabilities to cut down on time and make our lives faster.
Okay, thank you, Odi. And moving to the next question, is the SAR certification test within the scope of simulation?
Yes, I didn't include it, but yeah, as for you, for those attendees that don't know, SIR certification is basically a biocompatibility certification. So I don't know, you have your phone and you have to put it next to your ear. So we want to see that the radiation is not affecting the eardrums and everything here. And we need to pass also this test. And thankfully, yeah, you can do this in simulation, and Ansys has even a very rigorous and extensive data set of different organs on different frequencies and their permeability or permittivity, etc. So there is a very big data set only for the human body in Ansys libraries.
Okay, that was also the last question we had. So I would like to thank everyone again, and please feel free to register for our next webinar on June 4th. I will send the invites out as well. And as already mentioned, you will receive the recording and the presentation slides later this week. So thank you again for joining, and
Thanks,
hopefully
everybody.
see you next time.
Yeah, see you in the
Bye.
next one. Bye-bye.
Goodbye.